What we've seen in our Shell fleet is that there's a further 25% reduction, which we can achieve relatively straightforward while using energy efficient technologies, things like flattener rotors, using wind, and also air lubrication.
We've got 4 ships with air lubrication systems on board today, and we've been working together with other partners in the industry, and we're happy to share some of the experiences we've received there. Those are typically, and that's probably where we get the single biggest component on our propulsion load saving of around about 5% on average. We've found air lubrication to be helpful, be useful. We've shared that experience, and we're now on the 2nd or 3rd generation of pumps that are being used by Silverstream and these other companies, and that's made a massive difference to the payback period.
We took it upon ourselves to put air lubrication on a ship and see what the results were going to be on an LNG vessel, and that's been in operation now for over a year. And we're seeing consistent 3 to 5% improvement based on that.
Similarly to what Tom elaborated on from Carnival, we have tested different solutions both to reduce hull resistance or optimize propulsion efficiency, such as, for instance, new types of paints, underwater paints, the use of air bubbles also, installation of propeller bus cap fins, as you also mentioned, propeller nozzles, and so on and so forth.
The important part is integrating the technologies into the design rather than just sort of adding them and shoehorning them in. So actually spending time with the shipyards to see how the holistic design is impacted. And I think Richard started to touch on it, where he's using shaft power generators to power his compressors that feed his air lubrication system. So starting to bring the whole plant together and actually seeing a much bigger benefit.